Yes, thank you all so much for being here this morning. This is amazing. Just a really fun opportunity to have two experts in the meteorology field come and join us here at ABAC for this first ever mini symposium on weather. So thank you for joining me on this. So I'd really like to thank our speakers for coming. And so if you're able to hang out for an hour or 2 hours, whatever it is, thank you for being here. Just listen to, a lot of experience, really. I mean, combined experience, what are we talking, 25 years, 30 years?
25.
Yeah, plus how long have you been going?
20.
Oh my goodness gracious. Wow, okay. That's incredible, right? A lifetime of experience here, so it's really, really amazing. So we have food and coffee that's sponsored by the ABAC Honors. And so I really want to thank them for hopefully giving me a refund on that money. And fingers crossed. And then we do have some rain gauge giveaways, and so if you stay at the right moment, you might get one, okay? And then we do have a really fun thing. In between our two speakers, we have our ABAC Poet Laureate coming to give a reading of, or recitation of some poetry on weather. I don't know, let's get excited. Anyway, first of all, I'd like to welcome Parks Camp. You have your program in your seats. You can see his bio, but obviously works with the National Weather Service. Been going there for many, many years. He's based in the Tallahassee office, and so I really, really appreciate him just taking the opportunity to drive up a couple hours and join us here in Tifton, since they're our weather forecasting office. So thank you so much. Come on out. Appreciate it.
Thanks, Michael. All right, thanks, Michael, and thanks for the invitation to come out today. Yeah, my name is Parks Camp. I'm from the Weather Service in Tallahassee. I realized I didn't put Tallahassee on the slide here today. So, and it's the Weather Service office that covers up into South Georgia up here, and then also a couple other areas, and I'll go to that. So, what I'll talk about today is kind of a broad range of things here, and I'll touch on a couple different things. We'll talk about the Weather Service in general a little bit. We'll talk a little bit about some of the stuff we do with severe weather, a little bit we do with hurricanes, and then I'll touch on a little bit about some of the recent weather events that have impacted South Georgia, especially a little bit with Hurricane Helene and then the recent winter storm and that kind of thing. And I will also want to leave some time at the end for discussion for sure, and any questions that you have for me about the weather or what the Weather Service does or anything like that. So we'll kind of do things like that. All right. So first off, a little bit about what the Weather Service is and how we're organized. So we are a federal agency, and we fall under the Department of Commerce. And then under that, you have NOAA, so National Oceanic and Atmospheric Administration. And then under that, you have a bunch of different called line offices. So that's things like the National Ocean Service and Marine Fisheries and some other things like that. And the Weather Service is one of those offices. And then even under that, the Weather Service is made up of a bunch of different pieces under that. So you've probably heard of some of these pieces like the National Hurricane Center and the Storm Prediction Center. So that's the SPC, that's Severe Weather out in Norman, Oklahoma. And the local weather forecast offices are one of those pieces there. Also have weather forecast centers and things like that. So that's the pieces that make up the National Weather Service. So local forecast offices are part of what I am. So that's where I'm located. And we take care of the kind of the local forecast broken up into different parts of the country. Like the Hurricane Center, they do the hurricane forecast. Storm Prediction Center does some of the larger scale severe weather forecasting. Weather Prediction Center there, they do some of the larger scale like rainfall forecasting and larger scale forecasting as well. There's even a few other national centers as well that we'll talk about. So the Weather Service, our mission statement, so our overall mission is provide weather, hydrologic, and climate forecasting warnings and impact-based decision support services. But really the key thing here is protection of life and property, enhancement of the national economy. So that's really what our goal is, protection of life and property, and that's what we're generally trying to do. We're operating 24 hours a day, 365 days a year. So at our office, there's at least 2 people there all the time, every day, 24 hours a day, holidays, nights, weekends, everything. So we're always there monitoring the weather, whether it's sending out warnings, doing routine operations, or anything like that. So that's kind of what our goal is. So I talked about kind of these national centers a little bit, like the National Hurricane Center is one of these. You've got the Weather Prediction Center up in College Park. There's several of these. All the modeling, stuff like that. So you hear of things like the GFS. You've probably heard of those, like those models, things like that. These are all kind of run from up in our national centers up in the DC area. But then you have Storm Prediction Center, which is out in Norman. You also have Aviation Weather Center. They do large-scale aviation forecasting for the aviation, air traffic and that kind of thing. We also have space weather prediction, so they deal with things like solar storms and impacts from solar storms on, like satellites and stuff like that. So they do forecasting for things like that. You also have the Climate Prediction Center. You also have, not on here, you have the Tsunami Warning Prediction Center as well. So there's lots of different national centers there that do things on a kind of a larger scale. And then as we move down to the local offices, so there's about 122 or so of these local offices that do the forecasting and the warnings on the local scale. And so Tallahassee down here, see with the arrow there, so that's our area there. It covers Southwest Georgia. Jacksonville covers Southeast Georgia, and then Atlanta and Charleston and Greenville-Spartanburg cover, and Charleston, Columbia, and Charlton, and Greenville-Spartanburg actually cover other parts of Georgia as well. So Georgia gets sliced up with a number of different offices there. For our Tallahassee office, so we cover a good chunk of the Panhandle of Florida, also into Southeast Alabama as well. So we've got parts of 3 states that we cover as well. So pretty good area there. But you can see how it's kind of divided up across the country. So we have lots of local expertise that we provide to the different areas of the country. And so we provide the warnings and the local forecast for those local areas. Here's a little zoom in of the area we have here. You can see we get Dothan, Albany, Valdosta up here to Tifton, and then parts of the Panhandle and the Big Bend in Florida. And we also do marine forecasts out of the Gulf as well. So we go out to 60 miles out of the Gulf and provide forecasts out there as well. Excuse me. So we have 48 counties, which is a lot of counties thanks to the small counties in Georgia. So lots of counties in Georgia. I did grow up in Georgia, and so growing up in Georgia, how many people grew up in Georgia? Most of you probably, yeah. Did you have to do Georgia history and name all the counties? Not fun. Yeah, so, I did that a long time ago. So our office is located on the Florida State campus down in Tallahassee. This is a picture of our operations area there. So this is where we're doing all of our forecasting work here. You can see we've got these different workstations set up here. We've got like seven different workstations set up in there, so we can have basically in full operation, say if we've got a big weather event going on, something like that, we can have 7 different forecasters doing basically whatever they need to do at any of those workstations there. So this system here with the screen there is called AWIPS. That's our primary forecasting operational tool there that we can basically, that's where we issue our warnings from, where we generate our forecast from there. So we can look at our radar data there, look at our satellite data there, look at our observational data there. That's where we issue our warnings from, like I said. So anytime your phone goes off for a warning, anything like that, that's coming from our office here. It's coming from those systems right there. So that's coming from a person sitting at the desk there, monitoring the radar. It's kind of pushing the button and sending those out. So the different kinds of things that we do with from the office forecast, we do lots of different types of forecasts. We support aviation operations, so we do forecast, aviation-specific forecasts for multiple airports around the area. So these are called terminal aerodrome forecasts. These are support like airlines and general aviation as well. So for Tallahassee, for Panama City, for Dothan, for Albany, and for Valdosta, we do forecasts for those at least every 6 hours. And so those are like a point-specific forecast that we do. We do river forecasting as well, so it's the hydrology there. We do the marine forecast, like I said, over the water. We do fire weather forecasts. So we do forecasts to support support for prescribed burns, so burns going on state and federal lands. We're doing prescribed burns and also wildfires. So when there are wildfires, we provide weather support for those things that are going on. So we had several wildfires earlier this week when we had the really windy conditions. We had several wildfires that we provided support for down in over in the Panhandle. And then, so this is, and then fire weather kind of leads into the decision support services. So we provide a lot of support at the local and the county, the city, state, and federal levels to emergency management. So county emergency management, city emergency management, state emergency management, those kinds of things for different events, whether they be weather related or public safety related or anything like that. So we provide support for those kinds of things. And then we have different types of observations that we do as well. So we have our radars that we operate and maintain. So we have technical staff in the office that maintains those radars. They are highly mechanical and lots of moving parts, lots of electronics, and take a lot of work to maintain. So those have to be maintained. We have observational equipment as well, so our observational equipment has to be maintained as well. So we have technicians to do that as well. And then we have observations. So our office, in normal times, we do radiosonic observations, so that's our upper air balloon observations. Currently, we're not doing those. So like I said, we are in the university building there, and so which is an unusual situation of weather service. So we launch balloons off the roof of the building. So we cannot, typically, most offices use hydrogen to fill their balloons, which hydrogen is flammable, right? So it tends to catch on fire, which they don't like to do in university buildings. And so we have to use helium, but there's currently a global shortage of helium, and it's extremely expensive. So we've had to stop doing that for now. But typically, this is an example of a radio sound here. This is an older model. It's pretty beat up and everything. But I'll pass this around and you can kind of see. So this is the sensors on that. So these are GPS. They have GPS inside them that's tracked. And that's used for the wind. And then you have the temperature sensor and a humidity sensor on here as well. So you're basically getting wind, temperature, and humidity for these, as these are attached to a long string in the balloon, and they go up to roughly about 30,000 meters, 100,000 feet or so on the balloon. So I'm going to pass that around. Yeah, so they're mostly styrofoam, and so not very heavy. Anything like that. So that. All right, and then obviously beyond all that, we're still doing our forecast every day as well, and then any warnings or anything like that we have to do. So our forecast is done through, like I said, our AWIP system, something called our graphical forecast editor, and we do our forecast on a 2.5 kilometer grid. So the grid box is 2.5 kilometers where we do all of our parameters, our forecast. And so we do that on this thing here. Okay, yeah. So we got 2.5 kilometer grid boxes there that we do a forecast. So we do all kinds of variables. We do temperature, dew point, humidity, wind, waves over the waters, chance of precipitation, type of weather, all those kinds of things are done there. And all in this database. And then from that database, pull out a forecast basically on an hourly basis, on a 6 hourly basis, whatever. And that's what kind of feeds everything else. So our web pages and text products and those kinds of things kind of get pulled out of there. So if you go to our website, so weather.gov/Tallahassee, you can find some different things on here. So you can find our forecast discussion there. That's our technical discussion where you can go in and really get details on what we're thinking about the forecast, that kind of thing. And then you can also get other things, other types of forecasts that are pulled directly from that database. So a 2.5 kilometer grid database. So you can go specifically to a point and find exactly what you're looking for. There's a point and click map where you can go and click on the map and find that specific point forecast, exactly what you for the point exactly what you want to see. You've also got your active hazards on there if there are any active storms or anything like that, or any active severe weather warnings, anything like that. There's a 7-day point forecast there. And if you go into this as well, you can get down to an hourly forecast basically here for any particular point. It's going to give you an hourly graph of pretty much any parameters that you want that are in our forecast database. So you can look at temperature, humidity, dew point, wind, anything like that for a particular point in our forecast area, and see how those change over time on an hourly basis within our forecast. All right, so a couple other items that are pretty useful in terms of outlooks. So these are produced, this in particular is produced at the Climate Prediction Center. So these are longer range outlooks. Okay, and so these are probabilistic outlooks. Okay, and these are done on some different scales that you can go grab. So this one in particular is 8 to 14 days, but there's also longer scale outlooks for these as well. And these give you the probability of how things are going to look in, like say, in the 8 to 14, excuse me, 8 to 14 day period. So I pulled these off this morning. So what this is telling you here is that we've got a reasonable shot that we're going to have above normal temperatures in the 8 to 14 day period, and somewhat above normal. There we go. And then a somewhat above normal chance that we're going to have above normal precipitation in the 8 to 14 day period. Okay, you got to be a little bit careful with these because what they don't necessarily tell you is that it's going to be, you can kind of look at this and say, see that dark blue area over there and say, oh, it's going to be really, really, really cold. And that's not necessarily what it tells you. It tells you that it's very likely to be below normal, but it doesn't necessarily tell you it's going to be way below normal. So you got to be a little bit careful with some of those things. But it does tell you that it's definitely probably going to be below normal, say out west, in terms of temperature. And then over like in the east, in terms of precipitation, there's a pretty good chance in the southern Appalachians there it's going to be, you're going to get above normal precipitation. Doesn't necessarily mean it's going to be way above normal, but it's probably going to be above normal. All right, and then we also have the drought monitor as well. So the drought monitor is put together by a lot of different folks. There's a lot of different input. Pam, do you provide input to the drought monitor?
I mostly talk to Bill Murphy, the state climatologist.
Okay, all right. Okay, yeah, so this is from, we provide input from the Weather Service level, state climatologists provide input to this as well. So there's a lot of input that goes into this, and this is updated on a weekly basis here. And then this gives, and this is updated as well, and gives levels of drought across the country. So this is a really well-coordinated product here. There's also an Outlook product that goes along with this as well. That kind of predicts, okay, what things going forward as well. But this gives you, here it gives you the level of drought, starts with that normally dry in the yellow, goes up to moderate drought in the light brown. So you can see right now for South Georgia, we've got a normally dry and then into some moderate drought conditions as well. And then the S there stands for short-term there, which is for short-term drought conditions there. And hopefully, we've got more rain coming this weekend, so that'll help a little bit with that. All right, so we'll talk a little bit about severe weather products a little bit here. All right, talk a little bit about the SPC outlooks and then how that trends down. So you hear a lot about Tornado Alley, you think about Oklahoma and stuff like that. Well, we get a lot of activity here on the Gulf Coast and the Deep South. So this is a plot of the annual average number of tornado watches across the country here. And so these pink colors here are where you get higher numbers of these. And you can see actually, the Gulf Coast down here, even into South Georgia, along into the Panhandle, get a lot of tornado watches. We're very active in terms of severe weather down here in the Deep South and into South Georgia. And so it's a very active area. Tornadoes, we're really getting into the heart of the severe weather season now. Generally get into mid-February into April is kind of probably the peak of things, although a lot of times we get stuff in January as well. But we're kind of in it right now. In terms of severe thunderstorm watches, so that was tornado watches. This is severe thunderstorm watches, so a little bit different. That kind of slides off to the east, or it slides off to the west a little bit. But anyway, so when we think about our philosophy in terms of severe weather, we kind of think of a ready, set, go attitude, and kind of from the top down. And we start at the top with this ready, and it starts way out at like day 8 when we start looking at systems much farther out. And then that's kind of at the Storm Prediction Center. They do convective outlooks, which are broader, larger scale outlooks, and we'll show an example of that here in a couple minutes. Same thing from us. We'll start talking about these systems in our forecast discussions as well. And this is kind of the ready phase. This is just kind of keeping an eye on things, keeping a look at things, that kind of thing. As we move down to, excuse me, as we get down a couple days out, we get into the day 1 and 2 outlooks. Still kind of in that ready phase there. Like from our office, we'll start producing emails to our core partners, our emergency managers, that kind of thing. We'll start producing graphics and stuff like that to get people a little bit little bit readier. As we get into the day of an event, that kind of thing, we move into the set phase. Okay, this is the kind of the watch phase. All right, so your ingredients are coming together. You're in the watch phase now. That's kind of this set phase. This is the Storm Prediction Center. They issue the watches. Okay, and then the go. So that's the warning phase there. So that's within the hour of the event. That's things are happening on the ground. And you're getting things ready to go. So this is kind of the flow of information as we get out again. All right, so the Storm Prediction Center, like I said, they start really at day 8 with outlooks. They go out to day 8 and kind of see the evolution of one here. Out in the west here as things kind of evolve and get more and more certain as you get closer into time. And so you start with the outlooks, you work your way down to watches in the near term, and then warnings in the very short term when things are coming. Okay, and our outlooks are basically on a 5-tier system here, with marginal being kind of the lowest, so that's this darker green area there. So that's kind of a marginal risk there. Moving up to the slight risk, and then the enhanced risk, moderate risk, and high risk being the really high end, very rare thing here. We see that very rarely around here. I think 2017 is our last high risk here, and that would have been if you remember the Albany tornado in 2017 long track tornado that went through Albany and up the northeast of there several years ago. Okay, so really quick, I wanted to make sure I showed the definition of actually what we mean when we say severe weather. What constitutes a severe storm? So that's right over here on the right over here. So severe storm is going to have a wind gust of at least 58 miles per hour. It's going to be hail of 1 inch or larger, or a tornado. So a tornado is always going to be severe. So that's what we mean in terms of severe storms. So those are what the actual definitions are. Now we can bump things up a little bit, and we can give it a kind of another tag, and that's to be significant severe. That's if we get wind gusts of about 75 miles per hour, hail over 2 inches, and then we get a EF2 tornado on the EF scale. All right, and then I went over this a little bit here. But remember, so between a watch and a warning. Watch, kind of all the conditions are generally favorable for something to occur, and then a warning means that whatever we've got, either severe storm, severe thunderstorm, or tornado is imminent. It's time to take their action and get going. We've got lots of different ways you can get the warnings. Really the best way these days is those alerts on your phone. That's the WIA alert. So hope you don't turn those off on your phone, because those are probably the most prominent. So tornado warnings, a significant severe thunderstorm warning will also pop those up on your phone as well. All right, I'm going to go through the hurricane stuff real quick, and then we're going to move on to our some of our weather events here. So our hurricane season runs obviously from June through November. June typically you get maybe a storm every other year or something like that, and generally those are on the weaker side. We sometimes get something in the Gulf during that period. The peak really comes a lot later, during August into September. Middle of September is usually the peak, and then they start to drop off after that, and then falls off after that. But you can really see where that peak is, and that's really when the peak of the warm water is in the Atlantic and in the Gulf. That's when the best fuel for the hurricanes is, which is that warm water is available. Okay. There. All right. So it's interesting here. You can see where the favorite areas actually shift during the season. We start out in June there. If you want to see that, it's a little small there. So in June, best favorite areas are typically in the Gulf. It kind of starts out. So, or usually that's why if there's something is early, there's a good chance it's going to impact the southeast in some way. As we get into July, that kind of starts to shift a little bit. What happens in July, we actually have a little bit of a lull even. But then as we get into August, you start to spread out into kind of some of those areas you think naturally of hurricanes out in the Atlantic, in the middle of the Atlantic where they develop. And then as you get to the peak in September, you get these long track kind of storms that are starting out in the middle of the Atlantic. Hopefully they recurve, but you can still get stuff that develops in the Caribbean and in the Gulf as well. And then as you move later into the season, things start to shift back towards to the Gulf and the Caribbean as well. So it kind of starts in the Gulf and Western Caribbean, and then ends up there towards the latter part of the season as well. We use the Saffir-Simpson wind scale to talk about winds for hurricanes in terms of the category. So when you think about category 1, 2, 3, 4, 5, these are the differentiations between those. So a major hurricane is considered a category 3 or greater hurricane. Winds 111 miles per hour or greater. You just got to keep in mind that this is just for wind, so this doesn't take into account the impacts of the storm surge or the rainfall and the other hazards that are associated with hurricanes. So you can have a very large category 2 hurricane that can produce a devastating storm surge. And so you kind of got to be careful with just locking in on a category with these. Same thing with so watches and warnings with these. So watch is kind of a longer term product. So for a watch, you're expecting conditions in the next, possible in the next 48 hours, and then a warning in terms of tropical storm and hurricane as those conditions are more imminent. All right, and then you'll all seen the kind of the cone of uncertainty, right? Okay, so this is everybody's favorite product. It's kind of the bane of our existence in the weather service sometimes, because it can lead to some false sense of security and some misleading messages sometimes. And the biggest thing here is that it doesn't convey any of the impacts. So that cone is basically based on the track of the center of the storm, and it's created basically based on the average track errors from the past 5 years. So it does change a little bit from year to year, but it doesn't change from storm to storm. So doesn't matter what storm it is during a particular year, it's gonna look the same. And again, it doesn't convey any impacts. And so it's always going to be wide out at the ends. It's always going to be very narrow at the beginnings. It doesn't matter how big the storm is. So you can see here. So this orange circle here in this particular case is how large the area of tropical storm force winds is in this case. You can see it extends way beyond what the actual cone is. All right. And so the other thing is this is as well is that cone. What it represents is basically 60%, it's about 2/3 of the error, okay? So basically 2/3 of the time, the forecast track is gonna stay within that cone. So 1/3 of the time, the forecast track is gonna fall somewhere outside of that cone, okay? So, it's really only gonna be staying inside of that cone 2/3 of the time. So you really have to kind of keep that in mind. So a couple examples of how this can be misleading in terms of impacts here. So here is an example in terms of winds here. So this is from Hurricane Ike, which was a very, very large storm impacting the Gulf Coast. And you can see here the size of the cone there. And then our wind rings here. So that's hurricane force winds there in the middle, and the tropical storm force winds on the outside of that. Very, very much larger than just the cone that you see there. Next example here shows for Ike as well, the storm surge. Okay, and so these colors here show the height of the storm surge. You can see the storm surge extends well to the east, well to the west of where that cone is as well. And so that's a bit problematic as well. And then in this case here, you're looking at rainfall as well. So you can see there's lots of rainfall occurring outside the cone as well. Here's an example here. This is one of the cases here. So this is a forecast track here when this particular storm, this is Tropical Storm Isaac. So the forecast track in this case and the cone was to take it up into the Panhandle. The actual forecast track in this case ended up being in Louisiana. So this is one of those 1/3 of cases where it went outside the cone. All right, so here's a case here. So this is showing some rainfall impacts here. So what you're seeing in the green here are flash flood warnings as it loops through here. And what you see here is this is all rainfall here that was related to the Cindy here, but it falls well away from the center of the storm. And so people kind of focused on hurricanes. They think they're these kind of compact little things, but they tend to be, especially weaker, sometimes tropical storms especially, can be very broad, very wet, very large systems. All right. So one thing we've done, especially this past year, is we started overlaying all of our inland watches and warnings on these. So this helps to kind of expand beyond the cone to kind of show where the actual watches and warnings are over land, especially helps to convey a little bit better the impact. So we'll be doing that more in the coming years as well. And then I wanted to make sure I show this. This is always fascinating. We talk about the strongest storms. So these are your Hurricane Michaels, your Hurricane Katrinas, your Helenes, these big strong storms that make landfall, pretty much all of them undergo rapid intensification before landfall. Okay, if you look at all these storms as you go back through time, this includes Ian. So all these strongest storms, 150 mile an hour plus at landfall. The average time to become a hurricane is 50 hours before landfall. So pretty much all of these were tropical storms, just like 2 days before landfall. And then they typically, when they're really intense, they rapidly intensify right before landfall. So that's really probably the scariest thing for us. Is I don't as much worry about a really, really strong hurricane that's way out in the Atlantic, that's 4 or 5 days away, because it's probably a better chance it's going to weaken or go through some sort of cycle and not be an issue by the time it gets here. The ones that really concern me are the ones that I'm concerned that are going to rapidly intensify right before landfall. Gives you less time to prepare and those kinds of things. All right. So there's a preparedness link here. I'll make sure I'll share the slides with Michael so he can get these to you. But I did want to get to our events here so I can get through these. Here's Hurricane Helene. I've got one satellite image there from where it was over South Georgia after it moved inland, and then our radar loop there as it moved inland. Hurricane Helene was obviously rather unique, partially because because of the damage it did throughout Georgia and up into the Appalachians with the flooding. It was really interesting because of the intensity of wind that it kept as it moved inland. As it lifted north, it sped up as it approached land. I think we actually saw probably increase in damage from probably from Florida into Georgia. We didn't actually see as much damage in Florida as we did from Idalia last year. It actually increased as it moved inland, which we thought was really interesting. But again, rapidly intensified before landfall, and then moved inland. You can also see as well, the other interesting thing here, you see all this rainfall out ahead of the system up in North Georgia and up in the mountains. That was a key to a lot of the devastating flooding up in the mountains. So that's called a predecessor rain event, and that was a key to a lot of the devastation in the mountains. So a couple interesting things there. 140 mile an hour at landfall. Should have actually the final report from the Hurricane Center on this should be coming out fairly soon. They had a draft out fairly recently, so that should be coming fairly soon. Somewhere in the neighborhood of 15 feet of storm surge along the Big Bend coast there. So wind gust, you can see this swath as it moved inland, had easily probably 100 mile an hour swath, plus mile an hour wind gust that went well up and through pretty much all of Georgia, well inland there, which is pretty amazing to have that much of an inland extent of that. In addition, down here, probably 6 to 8 inches of rain as that went inland. So it was pretty interesting to see that hold together. But a lot of that was the fast motion, and it was also kind of the way it was integrated with some of the upper level features as it moved inland. A couple of pictures. These are from Lowndes County here. Some of the trees down there, and this is a power outage map from the next day, showing the swath of power outages through the area as well. And then I'll show this. So this is just unusual that we've got this many events in such a short amount of time. So you kind of started out in 2018 with Michael going into the Panhandle, and then into southwest Georgia, causing lots of devastation over there. And then you had Debbie last year, Debbie this past year, and Helene. The three of those almost made landfall in the same exact spot in Big Bend, which historically in the last 100 years or so, very few landfalls. All right. So a couple of these pictures are actually from Michael as well. So this is just impacts from both of those storms there. Lots of impacts to timber, lots of impacts to pecan orchards, which don't seem to hold well the wind. And then also infrastructure as well. A lots of your center pivots and stuff like that. All right, and then finally I'll get through this and then give some time for a few questions here. So our January winter storm that we just had, another pretty fascinating event here. This is an area shot from Thomas County, from Thomasville, from that storm. Here's a snowfall map that we kind of put together for this event. Again, this is pretty record-breaking snow, pretty much for the entire area. We didn't quite break our record in Tallahassee. That's just because we were right on the line where we were mixing with sleet and freezing rain and stuff like that. But pretty much everywhere else across our area, we probably doubled the records for snowfall for most locations. So it was pretty fascinating. We have 5 inches here in Tifton, and then some higher amounts even to the west a little bit. Pretty fascinating event. It's amazing to be able to get you have to get the right mix of cold air and then moisture, because you can't get too much moisture, because that generally ends up being too much warm air. You can't get too much cold air, because that ends up being too dry. And to get this mix is really pretty fascinating to get that right. So Albany, the previous record of 3 inches. I think 89 and 73 are kind of probably some of the benchmarks, like Valdosta was like 89, had a little bit more, and then the 73, I think Albany was Albany's record before that, and I mean they more than double that. So it's pretty fascinating to see this much snow. It's a pretty bad graphic, but you can see some of the other things on there. In the Panhandle of Florida, the old record was 4 inches. And there are like just dozens of sites that went by that, and multiple sites that reached like 9 inches or so. So they're working on verifying the records over there. So here's a satellite image post-event here. I had a loop that was too large to get into the presentation. But here is, let me see, let me make sure I can find it here. So Chattahoochee River is right there, I believe. There's the Altamaha right there. You can see kind of where get yourself oriented a little bit there. So you can see that kind of snowfall swath there. So that's just a pretty incredible shot there, going all the way back into Louisiana there. Seeing that snowfall after the clouds had cleared out there. Here's some of the damage that occurred in Florida, where you had some of the infrastructure at some of the nurseries down there, where they had covers over their plants, and those covers collapsed and did a lot of damage there. So I think the initial damage, from what I saw in some of the newspaper reports, was well into the buildings. So that's all I've got there. So I'm happy to take any questions that you have about the weather, any of these events, anything like that. I think the Weather Service does, or anything like that. So, yeah.
You need the cube.
Oh yeah, I have the cube, I guess, right? We have the.
Where is it?
It's in the, probably in the.
Oh, is it?
Was that hiding right
there?
there?
Here it is. Okay.
All right, so this is a weird one. So he's going to toss the cube to you, and then you just hold it in front of you, and it'll record you. You don't have to like hold it right up to you. Just talk.
All right, so in your speaker bio, I noticed where it said you're from Carrollton, Georgia.
Yeah.
I'm from North Georgia as well.
Okay.
How drastic is or is there any changes from the weather tendencies in North Georgia from South Georgia?
Yeah, I mean, certainly, yeah, you definitely have different climate, North Georgia, South Georgia. Growing up, it was always like I-20s, like winter weather-wise. I-20 is always like the cutoff, like for like snow and stuff like that. And Carrollton was always like on that line in terms of like winter weather and stuff like that. So there's always a kind of a difference there in terms of winter. And then you kind of have the fall line, so Augusta to Macon to Columbus, and that's also kind of, I think, a line. So you definitely have different climates. You have big elevation changes too. You've got the mountains in North Georgia and stuff like that. So definitely kind of different regimes, kind of north to south. Good question.
Can you catch.
Oh. What do I do with this?
Yeah, just hold it.
Oh, okay. I was wondering about the spaghetti models that we usually see on TV. Could you explain a little bit, please?
Yes, so the spaghetti model plots that you see, so what that is basically is that's just taking all of the different models that are run, and there's dozens and dozens of models, and each of those has a, you know, you can plot the track for, say, a particular hurricane or something like that, and it just plots them all. And which is fine, but you kind of have to be careful with that. So the better way that we use those is that we will average those together, okay, and create like a, you know, create an average track from those, or we'll do other statistical methods on those. We will rarely look at a spaghetti plot and get a whole lot of information for those. What we tend to see happen is that our partners and stuff will kind of look at those spaghetti plots, and they'll look at the one either that they want to see or that they don't want to see happen, and they'll kind of focus on that. You know, they'll see the one that goes over their town, or they'll say, oh, okay, is that one going to happen? And well, that's just one of many possibilities, and you know. So what we'll kind of do is we'll look at all of them and we'll say, okay, where are they focused? Okay, where do most of them fall? And that kind of thing. So we'll look at in a more statistical kind of basis. Does that make sense? Yep.
So, I got a question about hurricanes.
Yeah.
So recently, like within like the last few years, you know, it seems like we're getting more of them, but it seems like they keep intensifying. So like within the next few years, do you think we could continue to see that trend of them like coming more and intensifying also?
So yeah, it's interesting. We'll kind of see what I've noticed, and I don't have anything like peer reviewed or anything like this. But we've seen in the last, what I've noticed in the last few years, that we've kind of seen like a few years ago we saw a couple of years where there were a lot of middle Gulf years where we had a lot of storms going into the central Gulf, and then the last couple of years we saw a lot of storms come into the northeastern Gulf. And so sometimes we'll get patterns that will kind of favor particular areas, and a lot of times that'll be in a particular year where you'll get patterns that are favor a particular year. In terms of intensity, there's kind of mixed signals in terms of overall intensity. What concerns me most is intensification near landfall, and we have seen that a few times, especially in the Northeast Gulf, that since about 2016, that we really didn't see for, you know, at least like the 30 years before that. You know, starting really with Hurricane Hermine in 2016, I think. That one intensified at the landfall in the Northeast Gulf. Before that, kind of conventional wisdom for the Northeast Gulf especially was generally storms coming to the Northeast Gulf would be generally be weakening because there was generally kind of some cooler waters, shallower waters in the Northeast Gulf, and then because of the way they were getting pulled to the Northeast, there would be shear and things that are generally more detrimental. And then we've seen some several examples where that hadn't been the case in the past few years. And so that's something I think that's got to be looked into further, see if that is just I think the jury's still out on if that's just a quirk, something that just kind of happened, or if that's an actual, you know, an actual trend, something that's being caused by something else. So I think the jury's maybe still a bit out. Yeah.
I got two questions real quick.
Yeah.
In your personal opinion, do you see them adding a Cat 6 on the hurricane model?
No, probably not. I don't think so. I think once you get to 155, 160 miles an hour, it doesn't really matter beyond that. So I think your damage is done at that point.
And then what is the difference between the American and European
The models? Okay, yeah, so I mean, so you got the GFS models, so that's run obviously here in the US. The European models run over at the European Center for Modeling. So there's different physics, so different computer code, different things that are run. They're run at different resolutions, that kind of thing. And so there's just different ways to run the model. So they're just run a little bit differently. Each of them different tweaks and different kinds of things like that. So the European is good in some cases. The GFS is good in other cases. That kind of thing. What's really important is that they both run what's called ensembles, which is they take their initial conditions, so like they start out, and then they run multiple versions of the same model, just changing the initial condition just a little bit, so they get multiple solutions. And then she was talking about the spaghetti plots, and you get lots of these little spaghetti plots, and then you can do statistics on those to find out, okay, what's the most likely solution, and that kind of thing. And both of the systems do those, and that's kind of the most useful output that we get from both of those. Yep.
When you were talking about the convection outlooks, what specific things are y'all looking at to make those predictions?
Yeah, so for the convective outlook, so we look at a lot of different things. So we look at instability, so how unstable the atmosphere is. We look for how much moisture there is in the atmosphere. We look for wind shear, so we look for changes in wind speed and direction as you go up and down in the atmosphere. Especially for severely weather, we look kind of low down in the lowest couple miles of the atmosphere. We're looking for how strong the winds are and how much they change speed and direction as you go up and down. So there's a lot of the key things we're looking for for those outlooks.
We got a few minutes. Any other?
Those are good questions.
So my wife and I bought a sled for the. Is that going to happen again, or should we sell that?
You might want to get that on eBay. Yeah, that's probably a generational type event. I would say.
Question? Oh, he's gonna throw you some physics.
No, I was going to ask about the air pressure. You said the sensory device over there measures the wind speed, measures the temperature, measures the humidity. What about the air pressure?
Yeah. There's an air pressure sensor, and internally there's a pressure sensor as
And
well.
what is the role of the air pressure? In the, let's say, talk about hurricanes, they talk about depressions. And
Yeah. So I mean, the air pressure, like say in a hurricane, that helps determine the intensity. So the lower the pressure, okay, in the middle, the more air is kind of moving in to fill that in, right? So the lower the pressure here, higher the pressure here, the tighter the gradient, right? Okay, so the faster the wind speed there. So.
and the pressure is also included in the modeling.
Yes, absolutely. Yeah. It's a key component in the models is
Speaking about those
pressure.
convection patterns.
Yes.
Can I have another question? When we moved to Georgia, the reason we chose Georgia to live in was because we didn't want to live in Tornado Alley. But then we were hearing, I don't know if it's a rumor, that Tornado Alley is kind of shifting. Is that true?
Well, so I don't know that it's necessarily shifting or that it's always been in place necessarily, right? Populations have shifted a lot. I think that, but I do think that there's definitely, you definitely have a secondary tornado, swath in the Deep South. It goes, especially Mississippi into Alabama and probably a little bit into Georgia as well. But certainly like Mississippi into Alabama and those areas is kind of a secondary maximum of that's for tornadoes and severe weather for sure.
Oh, can I have another question?
Okay, sure.
I'm originally from the Philippines,
Okay.
and in the southern Philippines, we usually didn't get a lot of typhoons. We call them typhoons instead of hurricanes. But nowadays, there are more and more hurricanes that are going through the south. So is that like a symptom of climate change?
That's a good question. I don't know. I'm not too familiar with the trends of the typhoons and stuff like that. So I'm not 100% sure.
Okay, well, thank you.
Yeah. Whatever. Just use this. Just so I can hear you.
So I'm from Florida, and we have this thing called like hurricane season.
Yeah.
You know, it starts in the summer, ends in the winter, and you know, each year it's like when I was a kid, when I was 5 years old, we only had one hurricane a year, and that was free. It lasted longer. Do you think the hurricane season is going to extend?
So we have seen the last few years, we've seen a few, several years in the last few years, we've seen some storms in the early part of the season. Usually they're weak, like maybe in May, something like that. We'll see a tropical storm, something like that in May, those kinds of things. And then we've seen a few, especially stronger storms later in the season. It's another thing when I talk about something we need to kind of keep an eye on in terms of, okay, is this a short-term thing or is this a longer-term thing? Where we had, say, Hurricane Michael, which was in October, very late for a Category 5 hurricane in the Northeast Gulf. And then Milton. Milton was another late storm, pretty late in the season as well. So another one of those things where I don't know that we definitively know if the season's going to get extended. Certainly the oceans are getting warmer, and that is supportive certainly of stronger storms. But whether or not that becomes a long-term trend, because you do see over time, you see these over the scale of decades, you see kind of ups and downs in hurricane numbers, especially in the Atlantic. It depends on things like El Nino and some other oscillations and stuff like that. So, and we've definitely been in an upswing since the mid-90s, really, in terms of numbers of hurricanes. We should be, if kind of the multi-decadal oscillation, which is what that's kind of called in terms of hurricanes, we should be kind of at the end of that, but we haven't really started to see that go down.
Okay, yeah, last one, Claude. Here you go.
Kind of piggybacking off of like the Florida thing, I'm from like the Tampa area, and with future hurricanes, could you see the surge coming in more? Because I know like for Milton and stuff, Clearwater and all that area is like basically underwater. So I don't know if that would be a concern in like the near future.
Certainly, if you get more sea level rise, that would certainly be a problem. And if storms do end up getting stronger, and then Tampa itself has been relatively not impacted over time. I mean, even with Milton, Tampa itself got pretty lucky. South of Tampa, not so much, but Tampa has still gotten pretty lucky, and if they get a storm that goes just north of Tampa, then it's going to be big problems there. But there are concerns, I think, with sea level rise in terms of bigger impacts from storm surges.
And we could just go on forever,
Yes.
right? Thank you so much. Hey, let's just give a big round of applause. Thank you so much. Yeah, that was amazing. Okay, so thank you so much. It looks like it. Yeah. So hey, we have some rain gauges that we're going to give away. I'm thinking of a number, right, between 1 to 10. Whoever gets the closest gets the first one. All right. So call out a number if you want a rain gauge.
6, 4, 1.
Hey. All right, Cam, you get the first one. All right, brother. That's great, man. Okay, I got to think of another number. Okay. Because you were spot on. All right. Next number between 1 to 10.
6.
Wow, my goodness. Chill out. All right, okay. Now I'll do one more, okay? All right. Number between 1 to 10.
7.
8. 5. 3.
1.
Nice.
Thank you.
Awesome. That was amazing, right? Who knows how Dr. Mull's brain works? So cool. We'll do 2 more at the end. Again, thank you so much, Parks, for being here today. Now, I'd like to, this is a really fun interdisciplinary event. I'd like to invite Dr. Jeff Newberry up. He's our ABAC Poet Laureate, and he's going to do some readings and some recitations. He's a award-winning poet, and so I invited him just to come and share some poetry that he had put together, some writings he had put together related to weather, and he was gung-ho for it. So please come up. Thank you.
I think if there's like a circle of hell, it's being forced to sit and listen to someone recite poems. So I'm not going to keep a lot of your time. These are my first two books. I grew up in Northwest Florida, and so I grew up kind of hyper aware of weather. We lost a house in 1993 when Hurricane Opal hit my hometown. I lived from here to those offices from the water, and so I watched that wash away. Hurricane Michael hit my hometown. I saw a lot of my friends lose everything. Fortunately, I live up here. But ABAC was very supportive. I did a fundraiser and raised over $2,000 that year to go and buy supplies and help clean up down there. ABAC's been wonderful for me as a poet. I was telling Michael when I got here that sometimes I feel like the odd man out as the humanities guy at college, but this place has been really good to me. My first book was published in 2013 through a small press in California. The book ends with a long sequence called North Florida, an autobiography. I'm not going to read the whole thing, but I do want to read just one short section of it. When I was 14, 15 years old, I remember I had friends. All my friends were always older than me, 16, 17, 8 years old, and a lot of them volunteered search and rescue. And after a storm out on Cape San Blas, a house had carried across the road during the flood and set itself about 80 yards from where it was, and it was completely untouched beyond that. It was just floated across the road. And so this piece of a poem comes from that. It's called A Partial Memory of a Storm. The year I turned 15, a hurricane blew a beach house across Highway 98. The surge dropped it near a curled wreck of concrete and rebar. On the front porch, a laced pair of black boots set beneath a rocking chair. An untouched china hutch stood inside, each pearl inlaid dish unbroken. Sort of a poem I was trying in that long sequence to write these photographs. This is my third book, and it came out right after the pandemic, and because of that, it was basically ignored. We did, my co-author and I, who lives in Utah, we did a short tour. We did some readings in Jacksonville and Tallahassee, and it was reviewed a couple places, but overall it was ignored. But I still like this book. It's a sequence of letter poems. My friend Justin Evans is an award-winning poet who lives in rural Utah. I live in rural South Georgia. We've been friends for a long time. We met many, many years ago, and he and I read each other's work, we comment each other's work, and he had suggested, because they're both in a dry patch, to try writing some letter poems to each other, poems as letters. Epistolary is the word we use in my field. And so this poem comes from the end of this book, Cross Country. It picks up on the same ideas. It's a little more personal. This book is all about, it's about a lot of things. It's modal, it's about family, it's about politics, it's about weather, it's about the changing face of America. And so this one is short. It's called Letter to Evan. It's about hurricanes. In '95, Opal took our home just 3 years after my father breathed his last lying in a hospital bed. How my mother didn't kneel in rage and scream in the universe, I do not know. I don't know how she saw the hole in the side of that Bayside home and looked at me and my brother, big, awkward, bulky boys, and said, "We'll be okay." In '82, she lost the baby, a sister I mourn sometimes, the way you might an ancestor you've never met. Laura Suzanne, they called her, the umbilical cord tied round her neck in the womb. How my mother didn't find fault in herself, I don't know. Maybe she did. Maybe she lies awake some nights and wishes for ghosts, tangible and real. I still drive by the place our house once stood, that rented shack, weeds and tangled grass and sand, the palm tree gone, the slash pines gone, only sand spurs remained. Once I dreamed death drove a hurricane the way you or I might drive a car, dropped into gear as he headed toward the coast, revving the engine. He wanted to cause as much damage as possible. There's no place to stand after a storm's wiped a town away, man. You stare and gape at ghosts of buildings and wonder they were Riverwheel at all. Without the signs, the streets even have names. If you can't recall them, thank you for indulging me. Thank you for listening. I appreciate it. All my books are on, all the usual suspects, Barnes & Noble, Books A Million, Amazon, those places. So if you support your local writer.
That is pretty special. I really appreciate you coming to join us.
Thank you for having me.
Thank you so much. And that's what's so important, right? Weather is it's a part of our life, right? We exist in that. And so it's a joy just to get to hear that reflection, that creative. All right. I think we're going to work on some technology here and get this guy going again. Does she need it? Okay. Is that all she needed? Okay, great. While we're getting the computer up and going again, I'm going to just give a brief introduction. Pam Knox is our UGA climatologist, been working at UGA for a number of years. She's very well respected in the agricultural community and makes a lot of winter meeting and spring meeting talks. And so, and she's highly engaged in just helping producers know what's coming and how to plan and prepare for that. So we just really, really appreciate her taking time to come down from Athens to join us today. So are we good to go? All right, well, great. Well, let's welcome Pam Knox. Thank you so much.
If you guys need to get up and get coffee or something, I don't mind. I like to keep it relatively flexible. It's really good to be here. I'm a meteorologist by training. When I was in the 3rd grade, a tornado came 2 blocks from my house up in Michigan, and obviously made a big impression on me because it knocked down a bunch of trees. Fortunately, missed my grandfather's new Chrysler by a couple inches. And so I think if you talk to most meteorologists, they probably have a similar story. I don't know if that's true of you or not.
Almost the same story.
Almost the
In
same.
3rd grade, actually.
Yeah. Well, I was up in Michigan, and tornadoes are pretty rare up there compared to down here. Somebody asked about the Dixie Alley and that changing. It's like usually the trend in tornadoes is there's more in Oklahoma and Texas, and there's less in Dixie. What the trend is doing is it's going like this. So there's still more in Oklahoma than there is in the southeast, but the trend has changed so that the number is going down in Oklahoma and it's going up in the southeast. But the alley's still there. And so that's kind of an interesting thing. So what I'm going to do, I've got 2 different parts of my talk. I'm going to first talk about just some basic climatology, how Georgia's climate is changing, and how those changes could affect agriculture. And then at the end of my talk, I'm going to talk a little bit about the University of Georgia Weather Network, because a lot of farmers use that information when they make decisions about farming. And so some of this I've given before at ABAC. I talked to an ag journalism class a couple times here, but this is the first time I'm talking in this class, so that's great. So first of all, we talk about climate just in general. Climate can be described both in terms of what's going over a space, over an area, or over, at one point, over time. So I'm going to show both of those. This is just an example of a spatial distribution of climate. This is for 2024. It's the county precipitation rank. So the darkest greens are areas where they set a new record for the wettest year on record. The dark tans, well, there's really no of the really darkest tans, but show where it's been the driest. And so you can kind of see these spatial patterns. I spend my whole life looking at maps and graphs, and so some of you are probably more familiar with that, others less familiar with it. I'll try to talk you through it so you can see it. If I ask anybody in general, what is climate? They might say, well, climate is the average weather, right? Actually, the best explanation for the difference between weather and climate I heard was from a 3rd grader who said that climate is the clothes in your closet and weather is what you wear today. Which is, it makes perfect sense, right? Because when you look in your closet, you've got your winter coats on one end, you've got your shorts on the other hand, so you have covered the whole year. but whatever you're wearing today is because of what you know the weather forecast is for today. And so that's interesting. Climate, for a climatologist, is not just averages, but it's also extremes, ranges, cycles, trends, all that different stuff goes into describing what the climate is like. And so here's an example of looking at the climate at one location. This is for the state of Georgia as a whole. And it shows the annual average temperature each year from 1895 on the left side to 2024, which is the last complete year, on the right side. If you are a farmer, you are much more interested in that up and down from one year to the next than you are the long-term trend. Because whatever happened last year is probably not going to happen this year. Which makes it very difficult when you're a farmer because you need to know what those changes are like. But even in that, there's still some trends that you can kind of see. If you look, you know, people like to see patterns and things, just like you like to see pictures of animals and clouds. But you can see that there's sort of an upward trend from about 1895 to about 1920 or 25 or so. Then there's a decrease from that time to about 1970. And then since 1970, there's definitely an upward increase in the temperature over time. 1970 was a key year because 1970 was the year that the Clean Air Act went into effect, which means that usually the Southeast was getting a lot of soot from the Midwest where they were burning a lot of coal. And in 1970, Nixon passed the Clean Air Act, and the air got a lot clearer and more sunlight hit the surface. Since that time, the temperature has gone up here. Now, you know, it's not just that, because the whole world has that upward trend in temperatures. But here in the Southeast, we kind of got a double dose of it, because not only are we following the global trends, but we're also seeing the impacts of this more regional scale. And so temperatures are going up. This is for the state as a whole. There's a few stations in here that are city stations like Atlanta, but I would say 95% of the stations are rural stations, so it's not just an urban heat island effect that we're picking up here. And so that's something to keep in mind. And you can see the last couple of years have definitely been in the top 10. And there's no reason to think that's going to change. So it's going to continue to get warmer because a lot of it's related to, well, both the cleaner air, but also the warming trends with global climate change and greenhouse warming, which is going up. So in southwest Georgia, this is what we call a thermograph. There's a lot of information on here. I could talk for an hour about this, but I'm not going to do that. You can see the green band in there is the annual, is the daily normal temperature. Normal is the 30-year average. So you can see it goes up and down in the season. The warmest in the summer and the coldest in the winter. The reds are the extreme highs for each state, and the blues the extreme lows for each state. And they're scattered out. And then on top of all that is that gray bar, or that gray band of temperatures, which is the daily temperatures, high and low temperature for each day in 2024. And I was going to do Tifton, but Tifton has some bad data in it, so I picked Albany instead. So you can kind of see spring and winter, in the fall, we tend to have variable weather. It goes up and down a lot. And we have set 1 or 2 record highs last year. We did not set any record lows. But in the summer, generally, the extremes are not as widespread. The range of temperatures is not as high. This is where it's kind of the same air all summer. It's very rare to get a front here in the summer. And so when you talk about the climate, you're talking about all those different things together. Now you might ask, well, how is the climate changing? And this is all based on observations. None of this is based on models yet. So this is observations. The annual temperature across the United States as a whole is warming everywhere. This is over 100 years. You can see the Southeast has that kind of blue tint to it. That's because until the last 10 years or so, we're getting cooler because of that cooling period from about 1925 to about 1970. But now as we add more and more years to that time sequence, that blue is going away and the whole country is getting warmer. It's interesting to see the difference between winter and summer on the bottom there. Summer is not getting warm as quickly as the winter is. I think one of the biggest changes is irrigation. We're putting a lot more water into the atmosphere in the summer, If you put water in, you develop more clouds, keeps the soil moisture so you don't drop the temperature as much. And so you see it's mostly in the eastern United States where they do more irrigation, especially the wide-scale kind of irrigation with linear irrigators and so on. But winter is usually the season that's getting the warmest, and that's because the feedbacks with snow and ice. If you did global, and I'll show you this in the next graph, global temperatures are increasing the most in the Arctic because of the loss of sea ice and snow, both of which reflect sunlight back to space, and they change the energy balance. So I mean, climate, when it comes right down to it, is all about energy balance. Not much different than balancing your checkbook, right? If you got more coming in than going out, the balance is going to increase. If you got more going out than is coming in, the balance is going to fall down. So the temperature across the world and across the United States is increasing everywhere, but it's not increasing at the same rate. So if you talk to a friend in Wisconsin, which is where I went to graduate school, they are seeing much bigger changes than we are down here. And so you're not going to hear the same thing from everybody. Now precipitation is on the right-hand side here. You can see the green is where it's getting wetter, yellow is where it's getting drier, and for the United States as a whole, it's getting wetter over time. And it's broken down by seasons there, you can see in the southeast. Really it's getting wetter, especially in the fall. Maybe tied to tropical storms, maybe tied to more frontal rainfall that's coming in. We know that the humidity is going up, and that's because sea level temperatures are going up. Sea level temperatures are rising for a couple different reasons. One is because of global warming, because more sunlight is hitting the surface of the ocean. Also, again, some changes in the composition of the atmosphere due to soot from both, ships that are moving across. And we've really seen that in the last couple of years. The Gulf temperatures have gone up a lot. The Atlantic temperatures have gone up a lot. I really think that's contributing to the intensification, the rapid intensification of storms. And so it's likely in the future, as those temperatures continue to rise, we're going to see more of that happening. Most people don't really think we're going to see an increase in the number of hurricanes, but we probably will see an increase in the intensity, especially rapid intensification and more rainfall. And so that's something to keep in mind. Some of that fall precipitation increase might be from tropical storms, we just don't know. But every season has variations across the country, especially in spring and summer. You see more of that rain increase up to the north. That's because kind of the whole cycle of climate patterns across the globe is moving to the north as the equator, and all the heat around the equator kind of expands. And so it pushes everything farther to the north, and that includes the fronts where really most of the rain is coming from. Okay, so how do we expect temperature to change in the future? And this is now based on these models. Like the spaghetti models that they have for forecasting hurricanes, climate models also come in a lot of different flavors. There's a whole bunch of different ones. They tend to run them for different time periods, for different starting conditions, and use that as a way to describe what we think is the most likely thing to happen. And here these are showing, the top two are showing about 2050 or so. The bottom two are showing about 2100. So depending on how long you wait, you're going to get different results and things will be more extreme. And then on the left and right, there's two different scenarios about how humans are going to behave. Now you think it might be tough to predict the weather, but it's a lot tougher to predict human behavior because they're not always very rational. They don't follow the rules of physics very well. And so I think most people agree now that we're probably not going to get to the point on the right-hand side, the RCP 8.5, because we are making changes to, using more electric vehicles, doing things to reduce the amount of food waste, and so on. So I think it's more likely going to be the others, but there's still going to be changes. It's going to get warmer everywhere, and it's going to get the warmest at the poles. That's going to change the circulation of the whole atmosphere, because that is really driven by temperature differences between the equator and the poles. And one of the things that we may be seeing is that we get more wavy conditions. And so we get more periods of warm and more periods of cold as well. So the amount of warming that we get depends on how much additional greenhouse gases we put into the atmosphere. But one of the problems with that is, you know, these models can predict some things pretty well, like the average temperatures. That's not very useful for most farmers, you know, because the farmers are more worried about what's going to happen next week or next month than they are what's going to happen 20 years down the road. And so a lot of farmers aren't really interested in that because it doesn't really meet their needs for what they're doing this year. And so, you know, we have the UGA Weather Network to help with that. But they need to plan for this, because if you're growing cotton and you're going to spend $100,000 or more on a cotton reaper, it's going to take time to pay that off. And you need to know that 10 years or so down the road, you're still going to be able to use that. And so that is why it's important to think ahead a little bit farther. Also for things like infrastructure. If you're going to build a barn, you need to know it's going to still be useful. I know the people that grow timber are much more aware of this, because if you put a tree in the ground, it may sit there for 30 years growing before you can harvest it. And you have to know that that tree's going to do all right in 30 years. And so when you're looking at these longer term problems, then that's something where climate trends becomes much more important. I mean, if you're just worried about getting the crop in the ground this year, it's probably not that important. Then that year-to-year variability is way more important for decision making, not to mention the markets, the cost of inputs, and all that other stuff. We look at how precipitation is expected to change in the future. We do think water supplies may be more variable or less available in some places, and that's in spite of the fact that we're expected to get more rain. Because as the temperatures go up, so does evaporation and evapotranspiration. And so whatever rain falls isn't necessarily going to contribute to more rain in the reservoirs or in the ground. We do know we'll probably get less snow and ice and more heavy rain, especially in the summer. A lot of the infrastructure is really not built to handle that. If you look at how they design a road, if you know anything about civil engineering, they have to design to like a 10-year, 24-hour rainfall amount. But the problem is those numbers are not stable, they're changing. And so it makes it hard. Things that used to fall maybe once every 100 years or so are now falling every 20 years. And that means that the culverts are going to overflow more often. So that's more of an issue. We do know that if you look at just the heaviest rain, which is about 2 inches in 24 hours, so 2 inches in a day, good heavy thunderstorm, they are increasing across the whole country, about 27% increase here. But other parts of the country, especially in the Northeast, are really going up much quicker, because they're going from more snow to more rain, and so that's a big change. In Georgia, the trend in annual precipitation is almost flat. It's pretty close to 50 inches a year. And if I showed you the graph for that, you'd see that there's a lot of year-to-year variability, but the trend is almost zero. The problem is if we have more of these heavy rain events and the total per year is staying constant, then you have to worry about those dry spells in between. Did I lose it? Okay, so the idea is if we have the same amount of rain per year, but we have less the rain concentrated into these short periods, then we have longer dry spells. That's important for agriculture because plants need rain. They need about 1 inch a week. I mean, sometimes 1.5 inches if they're in a really active growing season or growing stage where they're pollinating or something like that. So then you have to worry about that because there's going to be a chance of longer dry spells in the future. So irrigation is really key, and now it's a major risk management thing that you can do, and you get breaks, I think, on your crop insurance if you have that. All right, so let's go on. I don't know if any of you are gardeners. One thing that we use to talk about climate is plant hardiness zones. That is tied to the lowest temperature that any place can expect to get in a year. And they've changed, they just updated that in 2023. You can see everywhere in the small map on the left is where it changed. Went up 1 category, so it went up about 5 degrees since the last map was done in 2012. And if you go on and look at what's going to be in the future, by the time we get close to the end of the century, half of Georgia is going to be almost a tropical climate. We're going to still get some frost, but it's going to be a pretty short frost season. And almost all of Florida is going to be in the tropics, and they're not going to really see frost anymore. And so those are the projected changes. That would be true whether you're doing commodity crops or you're doing garden crops. And so that's something we have to really watch. So if we look at how climate change is affecting agriculture, well, we know that the kind of crops you can grow depends on what the temperature is, because every crop has a temperature that you want to plant at, and you look at accumulations of degree days over time. You need to also consider other things like availability of weather. Variability is important because ecosystems depend on some variations. And so farmers would like it to be the same climate every year because that'd be easy to plan for. But ecosystems are adapted to have these variations in climate. Some years it'll be wetter and they'll maybe produce more seeds. Other years are drier and they are really much more unlikely to do that. And then also things like extreme cold and extreme frost. We've had some freezes this year. They came early enough so far that we haven't had too much damage. But as I was driving down here yesterday, peaches were blooming all the way from where I work in Watkinsville down to here, and probably to the south too. I just didn't go any further. If we get a freeze, we're going to lose most of those peaches. And so, especially if it's a really, really strong one. So I'm really watching that closely. I know the farmers are too, the weather services. I've been working with the weather service people to do their frost freeze predictions. And so we're still going to have a chance for snow in the future if all the ingredients come together right. It's just going to be rarer than in the past because it's going to be really hard to get the extremely cold air matching up with the really moist conditions that are coming in. I think the moisture won't be the issue. I think the problem will be we just won't be cold enough. But we're still going to see some of it. Extreme heat is going to be more of an issue because livestock are out in the heat, workers are out in the heat, and so that's something that anybody's going to have to plan for because they're going to be out in the heat more often. And people are already starting to adapt to that by having workers go out and work overnight when it's cooler, but it's also more humid because relative humidity depends on the temperature. And so that is something that we need to work on a little bit. I think I've got a map of that later on. So sort of a summary of climate change affecting agriculture. We'll get longer growing seasons because those growing seasons are dependent on when the last frost in spring is and when the first frost in fall is. And so that longer growing season may mean different crop varieties, different kind of crops altogether, or double crop it. Put in one crop, harvest it, put in a second crop after that. But it also means that if it's going to be warmer over the winter, you're going to have more overwintering of pests and diseases, which means there's going to have to be more treatments. That means more passes through the field with a tractor, or buying varieties that can, really stand up to that. Warmer winters may make it harder to grow things like peaches and blueberries because they expect to have cold weather over the winter. You can make some changes. You can pick different varieties that don't need as much cold weather, and that's really the way that things are going. But it does mean it's going to change how things go. And I think probably in the next 20 or 25 years, it's going to be almost impossible to even grow apples in Georgia anymore. Right now, mostly commercial apples are grown up in the Northeast mountains where it's cooler. But as it gets warmer there too, it's going to be harder and harder to find varieties that can put up with those relatively warm conditions. We do know that the more dry days that I talked about mean that either you have irrigation or you have to plant crops that can handle dry spells. Maybe something like sorghum. Or to figure out ways to do that. This is especially important for the small farmers who don't have irrigation. They can't afford it. There are ways that you can use farm ponds and things to help irrigate smaller plots at least so that they can help you get through that. We do know that carbon dioxide, as it goes up, does act sort of as a fertilizer as long as you have enough moisture. If you don't have the moisture, it's not going to be useful to the crops. And so that's something to keep in mind. Here we go. Climate change affecting outdoor workers' health and safety. The number of days above 90 degrees just gets worse and worse. Again, there's two scenarios here. The top one, RCP 8.5, we probably won't get to that level. But the one down at the bottom, certainly I think we will. And that one shows almost every day for 6 or 7 months of the year here in southern Georgia, we're going to have 90 degrees or more. And that's hard on livestock if you've got cattle, hard on workers if they're working outdoors in that. And so that's something that we have to keep in mind too. So you might think about, well, what's farming and gardening going to look like in the future? The problem is, these changes aren't just happening here, but they're happening everywhere else too. So a lot of our food now, I think 97% of broccoli that's sold in the United States comes from California. Well, California only gets 10 inches of rain a year. So they depend heavily on agriculture, on irrigation using this snow melt. But if they don't get snow, where's that water going to come from? They're already, if you look at the groundwater levels in California, it's really frightening how low they've gotten. And land has sunk because they pulled out so much water. So if we don't get broccoli from California, where are we going to get it from? Well, maybe some of you don't care if you don't like broccoli, but if you want to eat broccoli and you can't grow it yourself, then either it's going to come from somewhere else, or we're going to have to grow it ourselves. But we grow it here in the southeast. We've got better conditions than most of the country does because we have rain, we have water, and even though it's hot, broccoli doesn't like real heat. We can grow it in the spring and fall for sure. But that is something that is going to require a lot more insecticides and pesticides and herbicides and everything else than it is in California, where they're basically raising broccoli in a desert. And so that's a cost to the farmers because they're going to have to pay to put that out. And so that's something that we'll have to think about in the future. So if we look at how Georgia's climate is changing in the future, all the seasons are going to get warmer. Winter is the season that's getting warmest the fastest. The annual rainfall will probably increase. It really hasn't changed much here in Georgia in the last 100+ years, but if you look just at the end of that curve, it's starting to creep up a little bit. And so that is something we're likely to see. The growing season is going to get longer. That's got good and bad points to it. But there will still be winters because the sun will go lower in the sky at certain times of the year. They're just going to be rare and they're not going to be as cold. The water cycle is going to be amplified. We're going to have more floods, and we're probably going to have more droughts too. And so that makes it hard because that's something that farmers really depend on. They want this regular rainfall in. And then hotter conditions are going to put more stress on crops and outdoor workers and livestock. So I'm going to switch here from talking about the climate that's changing in Georgia, and I want to talk about the weather network. And there's actually quite a few different weather networks in Georgia. Of course, there's the National Weather Service. They have airport observations. They have the volunteer co-op network, although that has been dwindling over time. UGA has a weather network that we started in 1991, and that has gone on continuously since then. Georgia Forestry Commission has one that they use to monitor for fires, so they've been pretty busy this year because we've had a lot of fires in Georgia. They also purchase some of our data. EPD, Environmental Protection Division of the Department of Natural Resources, does air quality monitoring around Atlanta and I think Macon and a couple other cities. That's mostly done for air quality, so if there's a really high particulate day, like in the middle of the summer when you've got high pressure over us and no wind, then they will put out notices saying this is a bad day to be outside breathing all this stuff, and people will ask people to stay inside. There's a volunteer precipitation network called COCO-ROS. I'm the state coordinator for ROS, and they're in the middle of recruiting observers. You cannot use the rain gauges you got today for COCO-ROS. They are not good enough. Sorry. COCO-ROS gauges cost about $35, so I don't think we'd be giving too many of those away. But there's a lot of people who are very interested in this, and they go out and they have this rain gauge in their backyard, and they measure precipitation every day and report it on this website, and gives us supplemental information about the rain. That was helpful in doing things like studies of the hurricanes like Debbie and Helene this year because we got extra data points that we couldn't get just from the National Weather Service sites. The Department of Transportation has a network. They're mostly interested in whether or not the ground is going to freeze because that causes ice. And so they look at that. Usually their sites aren't too good for climate because they're right next to a big road. So we use those sort of for information that they wouldn't be useful for climate. And then U.S. Geological Survey is more interested in rain and water. They have precipitation gauges. If you go over a bridge, sometimes you can see a solid antenna on the gauge that goes down to the river, and that measures the temperature of the water or the level of the water, and they also often have a precipitation gauge. So the UGA Weather Network started on July 1st, 1991. It was at the Griffin campus, and that's because that's an ag campus, started by Dr. Gert Hogenboom, who was a faculty member of the Bio and Ag Engineering Department. This is before they changed and now have their own college of engineering. So the funding was through UGA salary support, plus we got grant money from a variety of places. We started out with 6 stations the first year, and we're up to 89 right now. We're going to add our 90th in the next couple of weeks. Because there's a new UGA farm, research farm at Perry. If you know where the fairgrounds is at Perry, it's just to the east of that. So they purchased a big farm there, and they're going to use that as a UGA facility, so we're going to put a weather station on there. So the network operates. We have basically 4 or 5 people working. We have myself, we have an IT specialist, we have 2 technicians who actually go out to all these stations and mow the grass and change out the instruments and so on. And we have 1 quality control specialist. We really need a programmer, but I can't afford it, so we've hired somebody else to help us with that. Our funding right now comes 40% from salaries, or for salaries from UGA, 20% from data sales, and then the other 40% is coming from NOAA right now. This is a big question mark because, as we all know, NOAA is one of these agencies that is kind of, feels like at least, it's in the crosshairs. We haven't heard any signs that we're going to lose the funding, but we just don't know. You know, and I'm sure we could talk a long time about that. But so far, at least, it looks okay. And so I think we'll be able to keep going. You want to know what a typical station is like? There's several here around Tifton. There's a lot of things listed here. Most of these are just weather variables that you would think any weather station would include. Temperature, humidity, wind speed and direction of precipitation, pressure, and so on. And you can see all those on there. There's also a lightning rod on there because we don't want the lightning to fry our instruments. And we do have some specialized instruments that are useful for agriculture. Those include the soil temperature. Got to use that for planting, right? I mean, I'm looking at corn going into southwest Georgia right now. It's because their temperature soil has gotten up to 50 degrees. That's what you have to have for corn. You're going to put peanuts in. Peanuts require about 65 degrees. And so it'll be a while before any peanuts get planted. And often farmers will plant corn early, harvest it, and then put in peanuts to cover the second half of the year when it's warmer already. There they always have to worry about the end of the season. If we have an early end to the season, they're going to have problems getting those peanut pods to fill. We also have solar radiation, and that's important for some crops like corn. And so that's something that the weather service stations do not have, but we have because we're an agricultural network. So we have a website at weather.uga.edu. You can go and look for Tifton and see what's going on there. It's got all the standard observations. It's got some calculated values like wind chill, heat index, wet bulb temperature, and some derived variables like chill hours for peaches or degree days when you're looking at the growth of corn and you want to know when to expect certain things to happen. And you might ask, well, who uses the Weather Network data? Well, a lot of people do. This is an example of the National Weather Service using it. The Weather Service uses our data to supplement their own observations, mostly for severe weather verification and flash flood verification. So this was an example from Byronville to the north of here on April 5 of 2023, when our station was directly hit by a tornado. Now, you know, that doesn't happen very often because we don't have that many tornadoes, and it's a pretty small foothold. It's a 10 by 10 foot area that they're in. But this is a picture of our Byronville station after the storm was hit, after the storm came through. It's looking from north to south. You can see there's a bunch of remains of grain bins down there on the south. And the wind, the anemometer on the station got up to 129 miles an hour before it got creamed by something coming off of those grain bins. So we don't know how high it would have gone. That's the highest we've ever measured. Here in southwest Georgia, the highest we've ever measured is 115 miles per hour in Hurricane Michael, because we were right, that was in Donaldsonville, and that was right in the eye of the storm, or in the eye wall probably. So all of a sudden I was watching And I noticed that the temperature went from about 60 down to minus 143, which is the default for it's not working. And so you can see that on the trace there. That's pretty much corresponds to the time when the pressure was lowest too, which is not surprising because you expect the pressure to be lowest when a tornado is going over it. And so you can see it started to rain there about the same time. So when the Weather Service did their post-storm survey, they have a little circle right over the Byronville station because that verified that it was an EF2 tornado. And so, and it's amazing that that station stood up through that. We have really long pins on the legs of the station that go 18 inches into the ground. So the whole tripod was really stable. But if you looked at this from a different direction, you'd see that the whole top part of the tripod was blown sideways because the wind caught the solar panel and just pushed it over. Other people who use the network data are the Georgia Forestry Commission for fire danger ratings, Agroclimate, which is a climate site at the University of Florida, very useful for doing analyses of degree days and things like that. I use that a lot because their graphics are better than we are, and we have a cooperative agreement, so they use our University of Georgia weather data. Scientists, I get calls almost every day, or mostly emails these days, asking for data for different graduate student projects or different scientist projects, needing to know what the temperature was like over the growing season. But it's also used by utilities for load forecasting. Small businesses, people who mow the lawns need to know how often it rains so they can bill their clients accordingly if they have to go out and irrigate or if they have to go out and mow. And the drought monitor as well. Although the drought monitor doesn't really handle short-term drought very well. It handles long-term drought much better. Our plans for the future, we're going to put this new station in at Perry. You can see this is what it looks like now. It's going to be a great place to put a station in because there's really no trees there. It's pretty flat. They're not going to, the irrigation map that I have shows that's not going to irrigate it. We've had to move a couple stations because they put in irrigators and the guns at the end of the arms will go right into the rain gauges. Does not work well for doing good rainfall measurements. And then we've got some work going on to do an updated database, updated website eventually. Depends on whether the funding continues. But I think, 90 is about all we can handle with 2 technicians. So I don't see that we're going to go above 100 unless we get a lot more money in. And that's all I've got for my 2 things there. I'm happy to take questions. I've got the cube here if you want to use it.
All right, who's first?
And I finished with before 11 o'clock. I love that.
Awesome.
So I'm more of a livestock background. How will the climate change affect, especially more in the cattle prices and stuff like that, especially if you're going to maybe have to change to a more heat-tolerant breed?
Yeah, there's some work now to bring in more crosses with Brahman cattle because they take the heat much better. And they've also worked with things like white Angus. So instead of having that nice black coat that absorbs a lot of sunlight, they now have white coats that are more reflective. So there's certainly some ways of changing the genetic makeup of the livestock to handle those warmer temperatures. Some people are going to putting cattle inside all day. There's places now that have dairy barns that are air conditioned, and they keep the cattle in there most of the time because cows that are not too hot give more milk. And so, there's different ways to do that. Or they put more, even if you put more shade shelters in your open fields, then they can get out of the direct sunlight, and that will keep them cooler than if they were out in the open. But I would imagine the market really is driven by lots of things, including what's going on in other places, whether or not you have to feed supplemental hay. It's been so dry this year that a lot of the farmers had to feed supplemental hay all winter, and the prices have gone up because everybody else wants it too, or needs it too. And so if we go into a drought this year, as I think we will, that's going to be a problem. If they can't get their pastures going, they're going to have to buy more hay or they're going to have to sell cattle. And those are just kind of the 2 ways that they do it.
Especially after last year whenever you had the bad outbreak with armyworms.
That's right, armyworms really did a number.
Yeah, we farmed back home, we only got 1 cut in hay.
Yeah, I know, it's crazy, because usually, what, you usually get 4 maybe?
Yeah, about 4.
Yeah. Other questions?
So you said that like the climate is changing to more like in the south, like, especially like southwest Georgia's going to like a more tropical. How long until it's like completely a tropical climate?
Well, it depends on how much carbon dioxide we put into the atmosphere. You know, the faster, I mean, the climate we're seeing now is based on what the carbon dioxide levels were 30 years ago. It takes that long to really build it up. And so it's going to continue to go up as long as we keep putting more carbon dioxide into the atmosphere than we're taking out. You know, and it's slowing down for sure. But I would say that probably in our lifetimes, of course you're a little younger than I am, but we're going to continue to see it going up. And maybe towards the end of our, you know, the century, we'll see it tapering off. And so there are no models that go beyond 2100. It's a blank screen. We don't know what's going to happen, but it's not like it's suddenly going to stop and go back to normal, whatever normal is, because we've changed the atmosphere. And until we change it back, you know, it's going to continue to change. It doesn't mean that Earth is going to die or anything, but it's going to be harder to live. Yeah.
So I live like a little bit west of the Midville Research Station.
Yep.
And what would you say like our climate differences between there and down here is like in
Yeah,
terms of production?
Well, they're a little cooler than we are down here. They're a little moister, but not much, because down here we've got more direct influence from the Gulf of Mexico. So if you look at the rainfall maps in Georgia, the highest rainfall in Georgia is up in the mountains. And that's because you get uplift from the mountains, so you get more thunderstorms and so on. The driest place here is right around Eastman. I think there's a kind of a hole there. If you're right along the coast, you get a little bit of sea breeze rainfall. If you're along the Gulf, you can get some of that as well. So if you're a little farther inland, you get less of that. And then as you go up to the northeast, it's a lot rainier. I think there's probably not a huge difference between up near Midville and down here. And probably humidity, it's pretty well mixed most of the year except for the winter. And so the winter would be a little cooler there. But overall, the whole year, I don't see huge changes. This year, I mean, they've been hit by more than one storm, which is really unusual. And it's so rare that we don't know what those trends are going to be. Most hurricane forecasters don't think the number of storms is necessarily going to go up that much, but they're going to be more intense. They're going to be slower because of changes in the steering currents, which is up at the level that airplanes fly. And if they're slower, it means they're going to drop more rain at every one spot. There's a rule of thumb for forecasting rainfall from hurricanes. 100 divided by the forward speed. That's not the wind speed around the eye, but the forward speed of the whole system in miles per hour is about the number of inches of rain to expect. So if you have a storm like Tropical Storm Alberto in 1994, it's moving forward at 3 miles an hour. 100 divided by 3 is 33 inches. And I think America's got 27. So that was actually pretty good. If you have a storm like Michael, which was moving forward at about 10 miles an hour, 100 divided by 10 is about 10 inches, which is a pretty good first approximation. So that if we have more slow storms, it's going to rain harder at those spots. But areas that are away from that path are going to be drier because we have sinking air outside the center of those storms. And that's why this year, in northwest Georgia, and even here in the southwest, where you were not really on the main path of the hurricanes, didn't get much rain, and they had a lot of problems with dry conditions later in the year.
So with the climate changing, I've seen some things where over time they could see like different regions going and growing in different things and getting away from different things.
Yep.
What's your take on that?
People are doing it now. I mean, right, we didn't grow citrus for a long time because of a lot of frost in the 70s. And most of the citrus production moved down into Florida because of that. It was also the coldest time period if you look at that graph for average temperatures. But now that it's getting warmer, they're starting to grow the more cold hardy varieties like satsumas. And a lot of that is happening down here. And so we're not only seeing satsumas, but we're seeing olives. Who would have ever thought we'd have olives in Georgia? It's not exactly the kind of climate you see like in Italy and Spain, but there's different ways to grow them that allow them to be grown here. Some places like pomegranates are starting to be looked at. Down in Florida, they're looking at growing vanilla, which is a tropical vine. And so people want to make money. I mean, they're farmers, right? They're business people. And so they need to grow a crop that's going to make them money. And so that's why they're doing this experimentation. I think with the citrus, another issue is in Florida, they have this problem with citrus greening. So by having a separate population in Georgia, they're trying to keep that way. I think with some success so far.
Yeah, so a couple things so the graph that you had with the Georgia temperatures over time, and it's something that we noticed it in Florida, I noticed it in Georgia a couple of years ago, and it's continuing in about 2015 or so. There's a step function there. Be curious to see if that continues, because it's pretty marked. And then combined with that, because you talk about with the warming Gulf and stuff, as we've seen an increase in moisture, and especially for us, when we've seen in the last couple of summers is we've had a lot more issues with heat-related products. We've had issues in terms of heat advisories and stuff like that. So heat index has really gone up. So heat index, that's a combination of your temperature and your humidity, right? And so that's a big impact on your workers and stuff working outdoors and stuff like that. And so I think you're going to see a big increase in that during the summertime as you see the temperatures and the moisture go up in tandem over time as well.
Yeah, I mean, it's interesting, the last few years, the ocean temperatures have gone up a lot. Some people are tying that to changes in the fuel that they're using in ocean-going ships. And the fact that they're putting out less particulates, the dark particulates that really absorb sunlight before it gets to the ground. So some people are thinking that that temperature rise is at least partly that. There's more shipping in the Atlantic than there is in the other ocean basins. But we don't know for sure. I mean, climate's a complicated thing. There's a lot of factors that are going in. So that's just one question mark.
My question is a little macro, not necessarily Georgia level. And you mentioned, I mean, two please. Technology has contributed a good bit in climate change, like combustion engine, coal-burn power plants. And recently, technology is making positive contribution too, like clean energy, carbon traction from air. How do you factor in the technological developments influence in climate change going in the future?
Yeah, I mean, it's an important question to ask, and it's hard to predict jumps in technology, right? I mean, because that's more human-driven, and so it's going to be hard to predict whether there's a new way, for example, to pull carbon out of the atmosphere. All the ways we know of now take energy to do, so that energy has to come from somewhere, whether it's nuclear or solar or the combustion engine. Well, combustion engines kind of don't help the problem because they're putting out more carbon dioxide. But I think, and that's why all these are just projections, and they're based on assumptions of certain behavior that may or may not be true, and that includes technology, because we don't know. I mean, there's some really bright people out there that are coming up with new plans. One of the things that amuses me about cattle is that they have found that if you feed seaweed to cattle, you can get them to eat it. Seaweed has the cattle produce a lot less methane than just eating forage does. Never would have thought of that, but there's scientists out there that are working on that. I mean, if you're thinking about, well, what can I do? Then you do simple things like you don't waste food as much, because a lot of the carbon dioxide is coming from food waste, up to 40%. And so those are the kinds of things that you can do. But technology is definitely going to have to be part of the answer. And there are some really interesting things going on. It's just that technology also has costs that you have to consider in the whole factor. But I think that's going to really help us a lot. Oh, yeah.
And this isn't so much a question, but really a challenge to the students that we have in the room. You are the future. You're going to be solving a lot of these issues.
Yeah.
And those that have had my class, you know, I always tell you, we have all this information, but what's the so what factor? You know, as I watch through this, and what's our primary row crops here in the southeast? Peanuts and cotton. When do we harvest them? September through November. What are we seeing? We're seeing increase in precipitation, so that's an issue. So, you know, you've got to be the challenger with coming up with a different variety that's a different growing time. So, you know, that's my challenge to each of you. Take all these pieces of information, you know, with the cattle. Black Angus has done a wonderful job marketing. But those black-hided cattle, we've got issues. So, you know, what are those things? So constantly be thinking, because when 2070 rolls around, I'll be 96. So I probably still won't be here, but, you know, I challenge you, you know, to always be thinking, and how can we do that?
And, you know, a lot of these changes are going to save the farmers money, whether or not it does anything for climate change, because it's going to change their economics. And, you know, I mean, I could be a physical scientist and answer all these things about physical sciences, but I don't do the farm spreadsheets. I don't know, they have to follow the markets, they have to know the price of all these different chemicals that they put in, they have to know what the cost of putting it out on a tractor is, because you have to pay for the fuel, you have to pay for the tractor. So they have to factor in all that. I just have to worry about the climate. So I had the easy part of that job, you know.
So I just have a question. How do you encourage producers to use the drought index and sort of think about it from, like, you know, to sort of estimate what's coming in the, you know, in the next several weeks, months, whatever, just to sort of estimate or plan for that? What do you feel like is the best application of that?
The drought monitor?
You're right.
The drought monitor doesn't make forecasts. They only say what they think is happening now, and frankly, it's very bad for short-term drought, like flash drought, like drought that's going to affect forage or corn. You know, in the drought of 2016, 2017 up in the northwest part of the state, they had a dry spell of 3 weeks in May going into early June. That happened to be the time period when the corn was pollinating.
Yeah.
They lost their whole crop in 3 weeks. I mean, timing is everything when you talk about what weather is doing. And we cannot predict it. The drought monitor didn't even show that we were in drought then, because the drought monitor works on really 3 months and longer. It will never capture that. That's why, you know, they look at the soil moisture maps from our network, because that's the only place that you know how dry the soil really is, unless you go and look at the condition monitoring reports that people send in. And so I think, I mean, there's a forecast for drought in the future on the Climate Prediction Center website based on long-term climate patterns. That is of some use, because it does say here in South Georgia we're expecting to go into drought this year. I think we're going to see it. I mean, you know, if you look at, since I came in 2001, we've had some really big droughts. 1998 to 2002, 2007 to 09 was really bad. That was the one in North Georgia where where the governor had a prayer day, which was very carefully picked on a day when it was going to rain. Hey, politics. And then there was the one in 2011 to 13, which was more in South Georgia, and it was, I think, arguably worse. But since then, we haven't had any of those really widespread droughts. We've had the drought in 2016, 2017 was shorter, and it really started up in northwest Georgia. Well, it really started even before that up in Tennessee. Remember, they had all these fires up there, and I could walk out of my office in Watkinsville and smell the smoke from all those fires in 2016. We had another drought in 2019. It was pretty short. We would have had a drought last summer if we hadn't had the tropical storm. You know, in Georgia, 30 to 40% of our summer rain comes from tropical storms. Not necessarily even the name storm, but tropical activity. And so if we don't get that, we're going to be in a drought. And I think the areas of the state that didn't have most of the rainfall from those really were pretty dry, and they're dry now. And so now that we're out of dormancy season, the plants are sucking up whatever moisture there is in the ground. And if we don't get rain this weekend, hopefully eventually we will. It's just gonna get worse. And so people are starting to plant corn now. It probably takes about a month before it pollinates. I am not a crop specialist, but you guys are. So, yeah, I think there's a chance if we don't see tropical storms this year, we could see a drought, and it could be a big one. But local storm activity is very hard to predict. We get one big storm or one front that comes over and just parks over us for a few days, and we can get a lot of rain out of that. And that could significantly change what's going on.
So I know some producers out in Greensburg, Kansas, and obviously the aquifer out there, drought is a big concern for them.
Yep.
And they've switched to a lot more sorghum and conservation tillage. What else could they do to like help mitigate the loss of aquifer out there?
Well, I mean, there's not a lot you can grow without water. Sorghum is probably one of the last things you can do because that's more drought tolerant than most things are. There are parts of the country that are getting wetter. You know, I mean, if you look at Minnesota, they have switched from growing wheat to growing corn because they're getting more rain. But if you're living out in the western part of the Great Plains, you don't have groundwater. You don't have. I mean, it's even worse in California, right? Because their groundwater's gone. Their snowpack is disappearing, and they would only get about 10 inches of rain in a year. Some of that all comes in one storm. Like they have an atmospheric river that they get that, and then they have to figure out a way to hold that in a reservoir or something so they can use it later. But while it's in the reservoir, it's evaporating, so they're losing that. So I think they have limited choices. Yeah, I hate to say it, but the Ogallala aquifer is almost gone in some places. And so it's going to be really hard. You can't drill a well deep enough to get access to good water.
I know we've gone over time. Thank you for your generosity and time. Let's just give Pam Knox a big hand. Thank you. What an important conversation, really. So thank you so much for being here. Just want to thank both of our speakers again. Thank you all so much for taking time. A couple hours drive, a 3.5-hour drive. So it really means a lot. So thank you all for coming out and joining us. Really, really appreciate it. We got 2 more rain gauges, huh? Who still needs one? All right. I got a new number in my head between 1 and 10. What is it?
It's 4.
6.
2.
Yeah, there we go. We won it this time. All right, who still needs one? Another number? What we got?
It's 4.
3.
6. 9.
10.
But what'd you say?
5.
No, what? No, what?
1.
No, I still hadn't heard it, but I thought did someone say 8?
1, 2,
I
3,
heard
4,
it.
5, 6, 7, 8, 9, 10.
I know. Someone said 8 a minute
In
ago.
your head.
I know, right? No, she heard it.
I thought I heard 8 too. You said 8.
Oh, I definitely said it.
No, yeah, all right. Who just needs a rain gauge? There we go. Awesome. Appreciate it. Guys, thank y'all again so much. Thank you for coming.